Hello, algebra students. Let's look at an application of what we've been doing. It says Janet has 169 tiles, each 1 square foot in size. Ooh, that's a hint, square foot. She wishes to use them to create a square patio. Ooh, she's going to create a square patio in her backyard. What will the dimension of her patio be? I was looking at this problem. I was like, should I have dimension or should I have dimensions? And actually, it works either way, and I'll explain to you why in just a second. But here's what I want you to notice. We have 169 tiles. Yes, we could call them a tile, but notice that each one of those tiles is 1 square foot in size. That means that the tile is shaped like a square that's 1 foot by 1 foot. And as soon as I see that language, I think area, because area is always measured in square units. So if I've got square feet, it might not say area, but this is definitely area. So we have area equals 169. Now, that being said, area of what? Well, look, she wishes to use them to create a square patio. We're looking at area of a square. Now, what are we solving for? It says, what will the dimension of her patio be? They're asking us to find the dimension. Now, I could have written dimensions. It sounds funny to say the dimension. But I was thinking about it. Why would I do that? Well, think about it. If her patio is a square, one way to think about a square is it's two-dimensional. It has a length and a width, that's for sure. A square is a type of rectangle. But another way to think about it is because the length and the width are the same measurement, we often just call that S, the side length. All right, so what are they really asking us to do here? They're asking us to find the side length given the area of a square. Well, hey, we can totally use our formula method to do that, as we've learned. And so we'll hit up the formula sheet and we'll learn that the area of a square is equal to the side length squared. Well, of course it is. It's equal to the side length times the side length, right? The area is just a special little rectangle with the two sides being the same length. Now, we will sub in what we know. And what do we know? Well, that 169 we said was that area. Since it was measured in square feet, it is the area, it is the A. So I will trade out the A for that number 169. And that is going to be equal to S squared. Side length is the thing I don't know. That's the dimension that's unknown here. And so it remains an S. And now it's just time to solve. We put in what we know. We could see that S is not alone. It is squared right now. So if we wanted to get it alone, we'd have to get rid of a square. Well, how do you do that? You do the opposite of square. The opposite of square is square root. And of course, we can do whatever we want to that equation as long as we keep those two sides equivalent. And so I'm going to take the square root of the left-hand side as well to keep the left-hand side equal to the right-hand side. Now you can do the square root of 169 in your calculator. If you did this on the GED, you would definitely have a calculator, but I happen to have that one memorized. I know that 13 squared, or 13 times 13 is 169, and so the square root of 169 must be 13. And that's going to be equivalent to what? Well, square and square root cancel. They're opposites, and so S is alone now. And so what did I just learn? I learned that that side length, that dimension of this square is 13. 13 what? Well, if the area was measured in square feet, this dimension is linear, meaning it's a line, is going to be regular, plain old linear feet. So just 13 feet. So the dimension is, we have a side length of 13 feet. You could also say that it's a 13 foot by 13 foot square. So 13 by 13. Again, that's recognizing the fact that it's 13 for both the width and the length. Now you might say to me, Kate, which one's right, this or this? And as usual, I say yes. They're both right. And so, well, how do I know which one to put on the test? They'll just either ask for the number on the test or it'll be multiple choice. So only one of those would be in the multiple choice answers because they're both correct. All right. Now, for those of you who are super mad at me because I did that with a formula when you think there's an easier way, let's look at that way. Okay, so Janet has 169 tiles, each 1 square foot in size. We're going to create a square patio. Could you just start putting tiles together? Sure could. Here's the smallest square patio. Well, I suppose the smallest square patio would be to just do 1 tile. That would be very tiny. But after that, we could do a 2 by 2 square patio, but that would only use up 4 of our squares. We could do a 3 by 3. Do you see why I like the formula better? But that's only going to use up 9 of our squares. So if we wanted, we could keep drawing this out until we use up all 169 of our tiles. So there's a 4 by 4. It's 16. Can I just write it out? I feel lazy. So 4 tiles by 4 tiles would give us a 16 use of 16 tiles. A 5 by 5 would give us a use of 25 tiles. We can get bigger than that. A 6 by 6 would be 36. So this is kind of a visual representation of how we could kind of guess and check this. 8 tiles by 8 tiles, we would use a total of 64 tiles. And 9 by 9 would use 81. Hey, we're getting closer. A 10 by 10 would use 100. 11 by 11 would use 121 tiles. Whew, I don't like this method. This is why I like formulas. A 12 by 12 would use 144. And of course, a 13 by 13 foot or tile patio, either way you think of it, would use up 169 tiles. Boom. We need a 13 by 13 foot square. All right. Whichever way you think of it, visually or with the formula, we get to the same place in the end. So hope that made sense to you, and happy learning.